Let's talk about height or altitudes of a triangle. Okay, so altitude, altitude are also called height of a triangle. This is a triangle ABC, and in this triangle, all the angles are actually acute angles. Okay, now as it is clear from this term height, that is also known as altitude, so it actually tells about the height of a vertex from a base. Okay, so if this is a vertex A and this is the opposite side to this vertex A, or it will also be called base in this case. So if you join this base or opposite side of this vertex, you can draw a number of lines, right? You can draw this line, you can draw this line, you can draw this line, and you can draw this line. Many lines, as many as you want. But there will be only one and only one line that will be perpendicular, on the base, on the line containing the base, line containing the base. And why is it important that we are focusing on line containing the base? The reason will be clear within a few moments, just when we'll move to the next slides. But this is very important. In this case, this altitude or height is this line segment that is making 90 degree or is right angle to this base BC. Let's say it falls here on point L. So this line segment AL that has been drawn from vertex A to on this opposite side BC, that is making a right angle, that is line segment AL, is one altitude. Okay, and remember that unlike median, it will not always go through the midpoint of the opposite side. There are some cases where the altitude in some triangles will actually be passing through the midpoint, but there are some separate cases. Those things you will learn when you will move to higher standards. In this standard, just know that by altitude or height, you only mean one thing, that it means a line segment that has been drawn from a vertex on the line containing the base, and it is making right angle on 90 degree. Okay, so this line segment AL is one altitude. Similarly, if I, let's say that, let me remove this first. So if I draw same thing from this vertex B, and on this side AC that is opposite to this vertex B, if we draw an altitude even from this one, let's say that it's actually something like this. Okay, and it is also making a right angle. Let's say it meets at M. This point is M. So even this line segment BM is also another altitude. Similarly, if you draw from this vertex C on this side AB that is opposite to this, so this altitude from here making right angle, let this point be N. So line segment CN is another altitude. So what is altitude? Altitude is the line segment that has been drawn from a vertex on the line containing the opposite side of that vertex, and that is making right angle. That is what altitude or height is. This is a right angle triangle. Okay, this is right angle. So if this is right angle, can you draw from this vertex A an altitude on this side BC? Well, you'll say that, hey, you know what? This line is actually, this side AB is actually already a height because it's already making a 90 degree on this side BC. And that is why this line is very important. Line containing the base or the opposite side of this vertex. So this is vertex A, opposite side is BC, that is, there will be some line containing BC, and this is already a height. So this line segment AB, which is already making 90 degree, is already an altitude. Same thing from this vertex C. From this vertex C, can you draw another line that will make 90 degree on this one? No, because this is already a line segment that is making 90 degree on this side, right? So from C also you cannot draw another altitude or height. So this CB, side AB and side CB or BC, whatever you want to say, these line segments are two altitudes which are actually the side of this triangle itself. Okay, these two sides are actually, which are acting as height or altitude, are sides of this triangle itself. Remaining is this vertex B. So if you suppose that if you draw a line segment like this, okay, that makes a right angle on this side AC, let's say it meets at point L. So this line segment BL is what? Another altitude. So this is one altitude, this is second altitude, this is a third altitude. So in this case, three altitudes. In this case also we have three altitudes, one altitude from each vertex. In this case we have one obtuse angle, and that obtuse angle is here. Now you will once again understand the importance of line containing the base. If I try to draw a perpendicular line segment, or say draw an altitude or height, do you think that we can draw here? No. This vertex A, since this angle is obtuse, will make an altitude or height that will, you know what, will actually lie here. And if we extend this, it should be a little perfect. Okay, so can you see that we have actually extended it, and it should be actually represented by dots. So my point is to show in dots, dotted line. So this is actually what this, we have extended this line, and that is what line containing the base. It is actually the extended base, that is the line containing the base, and it's making right angle here, not inside of this triangle, right? Not inside of this triangle, but actually outside of the triangle. So this, if it meets here, if you extend this base, and if this line segment intersects this extended base at L, then this line segment AL is one altitude which is actually outside of the triangle. And if you remember, when we were discussing about median, we discussed that when we draw medians of a triangle, all the medians lie within the triangle. Okay, but in this case you can see that we can have an altitude or height that is actually outside of the triangle. Okay, now you can draw from this vertex C, you can draw a altitude or height from this vertex on this opposite side, and that can be something like this. Okay, something like this. Though it's not looking very accurate, but we cannot do it better without protractor. Okay, and same thing here. Okay, you can draw from here. Okay, so in all these cases, these are actually making 90-degree from, you know, the opposite vertex. So you have, let's say it meets here at M, and this is N. So CM and BN, these three are altitudes or heights of this triangle ABC. We have a triangle ABC here, and this triangle ABC, this base BC or the side BC has been extended towards the right, and due to this it is making an angle here. So at the vertex B, the side BC has been extended, and this angle is actually called exterior angle. This is exterior angle. And what's the reason that it is an exterior angle? It's because it's lying outside of this triangle. Rest all the angles, that is this angle A, B and C, these all are interior angles because they are inside of this triangle. This exterior angle is, in this case, is angle ABD. Now, same triangle, but in this case, rather than the side BC being extended, the side AB has been extended, and due to this reason, at the same vertex B, now you have this angle as exterior angle. What's the difference? In this case, the side BC was extended, but in this case, side AB has been extended, and due to this, now this is the exterior angle. And what's the name of this exterior angle? Angle CBD. Similarly, same triangle, but in this case we have chosen a different vertex. In this case we have vertex C, here we have vertex C. In this case, this is an exterior angle when the side BC has been extended towards the left, but in this case this is the exterior angle when the side AC has been extended outside. The name of the exterior angle in this case is angle ACD, and the name of the exterior angle in this case is angle BCD. Okay. Similarly, one more point, that if we choose another vertex, that is vertex A in this case, so when the side AC has been extended upward, so this is exterior angle, and when the side BA has been extended outside, this is the exterior angle. The exterior angle in this case is angle BAD, and the exterior angle in this case is angle CAD. It means that at each vertex of a given triangle, you will have 2 exterior angles. Therefore, total 6 exterior angles for a given triangle. Okay, so we have learned about exterior angles, and in all these cases, this exterior angle, and if we take this angle and this angle, okay, so this is exterior angle at the vertex A, and the interior angles at angle C and angle B, and same thing here. At the vertex A you have the exterior angle, this is one interior angle and this is another interior angle. So this angle C and angle B, in comparison to this angle BAD, that is exterior angle, is actually interior interior opposite interior opposite angles. Again, at the vertex A you have an exterior angle. Here also you have an exterior angle. Therefore, the interior opposite angles in this case will be the interior angles at vertex C and vertex B. Similarly here also. In this case, this is our exterior angle at vertex C. Therefore, the interior angle at vertex A and the interior angle at the vertex B, even in this case, at vertex C we have an exterior angle. So interior angle at vertex A and interior angle at vertex B, these are actually interior opposite angles to this exterior angle. Okay, same thing here. This is exterior angle. Therefore, at interior angle at vertex C and interior angle at vertex A, these two interior angles are actually interior opposite angles to this exterior angle. When you come to this triangle, exterior angle here at B, therefore interior angles at C and at A, these two angles are interior opposite angles to this exterior angle, angle ABD. Okay, now interior opposite angles are also called as, remote interior angles. Remote interior angles. Okay, either you call them interior opposite angles or remote interior angles. Both these two names are same. So this was about exterior angle. Now let's discuss one very interesting property of exterior angle. In this case, we have vertex ABC. Side BC has been extended outside. Therefore, we have an exterior angle, that is angle ABD. This is an exterior angle, and let's say that to this exterior angle, that is this one, we have two interior opposite angles, and they are this one and this one. Okay, let's name them X and Y. Okay, let's name them X and Y. Now what you have to do is, if we take this angle as angle ABD, or even let's name it as angle Z, okay? We are naming this as Z. So if this is Z, then we'll now prove it that actually this exterior angle, that is Z, that is ABD, is equal to these two, sum of these two angles, that is X and Y. That is, the exterior angle is actually equal to the sum of interior opposite angles. Again, the value of the external angle will be equal to the sum of interior opposite angles, that is Z is equal to X plus Y. Now let's prove it how. So what I'm going to do is, I'm going to draw a parallel line to this one. So if we draw a parallel line to this one, let's say that this is a parallel line. So if this is BE, so this line BE, this BE is parallel to AC, Now, since this is parallel to AC, so focus on AC and BE. So can we say that this angle will be equal to this angle, this one? This angle will be equal to this angle. Why? Because they are alternate interior angles. They are alternate interior angles, right? So if you remember, In the case of a transversal to the parallel lines, alternate interior angles are always equal. Since these two lines are parallel, this is the transversal line of these two parallel lines. Therefore, angle Y is equal to angle this one. So this will also be equal to what? This will be equal to Y. Right? Now, again focus on same parallel lines, that is this one, and same thing here as well, right? But in this case, you have another transversal line, and that will be actually this one. So focus on this transversal line. These two parallel lines, and now this transversal line. Okay, just forget this one. So if you look, this parallel line and these two parallel lines and this transversal, so this angle, that is angle X, will be actually equal to this angle. How? Let me show you. If these two are parallel lines and this is transversal, then you know that this angle will be actually equal to this angle. Why? These two angles are actually pair of corresponding angles. So this parallel line and this parallel line, this is a transversal. Therefore, this angle will be equal to this angle because of pair of corresponding angles. That's why this angle will be equal to X. Therefore, you can see that now we have proved that angle ABD is what actually? This whole angle is what actually? Let me draw here. So if I have to draw it, this angle ABD, this is what? This is this angle, and this angle ABD is what? Is equal to X plus Y, right? X plus Y. So Z will be equal to X plus Y, right? Okay, so we have proved here that an exterior angle will be equal to the sum of two interior opposite angles, and this property is called as exterior angle property of a triangle. Exterior angle property of a triangle. Sorry, this is my shortcut to use triangle of a triangle. Okay, this property is exterior angle property of a triangle. Well, let's solve some problems related to exterior angle. If this is a triangle and 110 degree here, that is angle ACD is exterior angle and that is 110 degree, you have to find the value of X. Now for this exterior angle, you have this interior angle and this interior angle. So these two are interior opposite angles. One interior opposite angle and the second interior opposite angle. And we know that this 110 degree by the property exterior angle property of a triangle will be equal to 50 degree plus X. Therefore, it will be 110 degree minus 50 degree is equal to X. So X will be equal to 60 degree. So this value is what? 60 degree. How? By using exterior angle property of a triangle. Now look at this figure, triangle ABC, and we have an exterior angle which is being made by extending side BC. You have to tell, is there anything wrong in this diagram? Now, using what we have learned till now, you can see that this is external angle, and this 50 degree should actually be equal to, this 50 degree should actually be equal to this angle plus this angle. So if you add these two values, it's coming as 50 degree plus 50 degree. So it's giving you 50 degree is equal to 100 degree. That's wrong, right? It should not be. This angle should be actually, if these are 50 degree, if these are correct value, then this should be 100 degree, right? So it means that yes, there is some problem in the values given here, and since the sum is not coming, the external angle is not coming equal to the sum of interior opposite angles, that's why yes, there is something wrong. What is the angle sum property of a triangle? Well, according to angle sum property, angle sum property of a triangle, the total measure of all the three angles of a triangle, that is angle 1 plus angle 2 plus angle 3, will be equal to 180 degree. If you try to find the sum of all the three angles, then the sum will be equal to 180 degree. And if you have to justify your answer, then how will you do this? So in order to justify, what we have done is, we have extended this base AC towards the right. Okay, so this is the extended part of this AC. Due to this extension, you'll have an exterior angle. Angle 4 is an exterior angle. And here we can apply the exterior angle property of a triangle. Remember the exterior angle property that we discussed just in our previous video? Exterior angle property. According to exterior angle property, this angle 4 will be equal to angle 1 plus angle 2. Now since angle 4 is equal to angle 1 plus angle 2, this is one equation, and if you focus at this angle 4 and at this angle 3, so angle 4 and angle 3, these are two adjacent angles which are actually forming what? They are forming linear pair. Therefore, since they are forming linear pair, angle 3 plus angle 4 will be equal to what? 180 degree. Now since angle 4 is equal to angle 1 plus angle 2, so if you replace this angle 4 with angle 3 plus, if you replace this angle 4 with angle 1 plus angle 2, because we have just written here according to exterior angle property, this will be equal to 180 degree. If you rearrange it, this will be angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So we can clearly see that these steps are actually justifying the angle sum property, that is the total measure of all the three angles of a triangle will be equal to 180 degree. Okay. Now remember this angle sum property that we have discussed just now, and this exterior angle property that we have discussed in our previous video, but we just used here. Okay, because now we are going to solve some problems and we will use these two properties. We have here some problems, and in this you have to find this angle x, the value of x in these two cases. Now 50 degree, 60 degree and x, that's really very simple if you apply angle sum property here in this case. So applying angle sum property gives you what? It gives you that 50 degree plus x plus 60 degree, this will be equal to 180 degree. If you solve it, this will be x plus 110 degree is equal to 180 degree, and if you further solve it, this will be x is equal to 70 degree, right? So x comes as 70 degree. In this case, You have this symbol shows that it's actually 90 degree, right? This shows right angle triangle. So again, angle sum property, according to angle sum property, x plus 90 degree plus 30 degree will be equal to 180 degree, and this will be x plus 120 degree, and this will be equal to 180 degree. And if you solve this, this will be 180 degree minus 120 degree, and you will get x is equal to 60 degree. In these cases, again, you have to find the value of x. So in this case, x and 50, same angle sum property. So according to angle sum property of a triangle, x plus this x plus 50 degree will be equal to 180 degree. Okay. X plus x means what? 2x means 2 times x, 2 multiplied with x, right? 2x plus 50 degree is equal to 180 degree. This 2x and this 50 degree, if you apply transposition method, so 180 degree minus 50 degree, this will give you 2x as 130 degree. Now x will be therefore will be equal to 130 degree divided by 2, and therefore you will get x as 65 degree. Similarly here, in this case, according to angle sum property, this will be x plus x plus x. This will be equal to 180 degree, right? And if you add these three, you will get 3 times x is equal to 180 degree. And if you further solve it, you will get x as 180 degree divided by 3, and you will get x is equal to 60 degree. Now again, this shows 90 degree, that is a right angle triangle. Applying angle sum property, in this case, x plus 2x plus 90 degree will be 180 degree. This will, x plus 2x means 3 times x plus 90 degree will be equal to 180 degree, and 3x will be equal to 180 degree minus 90 degree. So you will get 3 times x as 90 degree, and x will be equal to 90 degree divided by 3, and you will get x as 30 degree. In this case, in these problems, you have to find the value of x and y in each of these diagrams. Now, in this case, you'll use angle sum property and the exterior angle property, both the properties here, because you can see that we are now dealing with exterior angle. We have to deal with exterior angles as well in each of these cases. So if you solve this one, you have to find the value of x and y. Okay. Now, if you straight jump to angle sum property, that is, if you do 50 plus x plus y is equal to 180 degree, then you can see that you have two variables here. So first you need to find one variable. If you look at this vertex, around this vertex, so 120 degree and this angle y, these are actually forming linear pair, right? Two adjacent angles, one common arm and two non-common arms. So it's a linear pair, and according to linear pair, y plus 120 degree will be equal to 180 degree, right? According to linear pair. This will give you what? Y is equal to 180 degree minus 120 degree will give you 60 degree. So now you have the value of y, that is equal to 60 degree. Now we can apply angle sum property here. So if you apply angle sum property, this will be x plus y plus 50 degree. This will be equal to 180 degree. Since we know that the value of y is 60 degree and this is 50 degree, so this will give you 180 degree, and this will be x plus 110 degree equal to 180 degree. This will give you x as 180 degree minus 110 degree means what? 70 degree. So you have two values now. X is equal to 70 degree and Y is equal to 60 degree. Let's solve for this one. In this case, if you look at this triangle, here you have X and here you have Y. If you look around this vertex, then this is one straight line, this is another straight line, right? So if around this vertex, these two angles are actually vertically opposite angles. Okay, I'm not going to write down here, just listen to it what I'm saying. It's vertically opposite angles, and since vertically opposite angles are always equal, therefore Y will be equal to 80 degree. How? Because they are vertically opposite angles. So we have this value here, that's Y is equal to 80 degree. We have one value. Now apply angle sum property. So 50 degree plus X plus Y, this will be equal to 180 degree, and 50 degree, the value of Y is how much? Is 80 degree plus X is equal to 180 degree. This will give you 80 degree plus 50 degree is 130 degree. So 130 degree plus X is equal to 180 degree. This will give you X as 180 degree minus 130 degree. This will be X is equal to 50 degree. Okay, so we have two values of Y and of X. In this case, if you look at this figure, then we have X as an exterior angle and Y is the adjacent interior angle of the X. So how to proceed? If you apply exterior angle property, according to exterior angle property, this X will be equal to 50 plus 60, 50 degree plus 60 degree, according to exterior angle property. If X is equal to 50 plus 60, then X is equal to 110 degree. So we have got one value. Now if you look at this vertex, this angle X and angle Y are two adjacent angles and they are actually linear pair, right? Common arm is this one, two non-common arms. So X plus Y will be equal to 180 degree. Why? Because they are linear pair. We know the value of X, that is 110 degree, and Y we don't know, we have to find that value. So Y will be equal to 70 degree. We have two values now. In this case, now you have three exterior angles and all of these angles are X, X and X. How to proceed? Well, very simple question. If this is X and if you look around this vertex, this straight line and this is straight line, this is X, therefore this angle and this angle will be vertically opposite angle, and vertically opposite angles are always equal, therefore this will also be X. Now focus on around this vertex, this straight line, this is straight line, this angle and this angle are vertically opposite angles, and vertically opposite angles are equal, therefore this is also X. Okay, now focus around this vertex, this straight line, and this is another straight line. So this angle and this angle, these two angles are actually vertically opposite angles, and vertically opposite angles are always equal. It means that Y is equal to X. This is very important. Now since Y is equal to X, you can very easily solve it. Now apply angle sum property in this case. Now if you apply angle sum property, then X plus Y will be equal to 180 degree, and X plus Y is equal to what? Is equal to X is equal to 180 degree and this will give you 3 times x is equal to 180 degree. So this will give you x as 60 degree. The three angles of a triangle are in the ratio 1:2:1. Okay, so this is very important. 1:2:1. The three angles of a triangle are in the ratio 1:2:1. Find all the angles of the triangle. So you have to find all the angles of the triangle, and what is given to you is that if this is a triangle, and if this is a triangle, then the ratio is 1:2:1. The ratio has been given to you. Let's suppose that one of the angles is equal to x. Let's suppose that it's a variable x. We don't know the value, we have to find that. So if one angle is x, then next one also be like it's in ratio 1:2:1, right? So if one is x, for this one it will be 2x, and for this one it will again be x. That is, two angles will be of the same ratio. It means that yes, they are of the same value, and this will be 2x. So 2x, and this is x. Okay, this ratio is very important. They are in which ratio? If one is in x, the next one will be in 2x, the third one will be in x. Now x, 2x, and x. You know that angle sum property tells you that x plus 2x plus x will be equal to 180 degree. If you add these, you will get 4 times x is equal to 180 degree. And if you look, this x is equal to 180 degree divided by 4, and you will get x as 4 times 4 is 16 and 45 degree. Okay, so x is actually what is 45 degree. So one angle is 45 degree, then the next one is 2x. It means that angle will be 2 times 45 degree means what? 90 degree. And this is x, it means 45 degree. So these are the three angles of the triangle.